Hey everybody, it's Mr. Corzine. I wanted to quickly go through the 7.4 notes with you. This is another way that we can learn how to solve systems. It's another technique that we have. In certain situations, it can actually be um, easier to multiply first. We always can do, we can always graph, but that's not really convenient most of the time. We always can use the substitution method. And that's, this is your big one right here, the one that you'll default to most of the time. But then you can add or subtract. And then finally, because you know how to add or subtract, you can now couple with that the fact that you can multiply first. And that's just going to help you even more. So let's go ahead and get started. Here we have 4x plus 3y equals 8, and then x minus 2y equals 13. They want us to solve by elimination, but right now we don't have we don't we don't have any terms that are the same or that are similar. So one of the options that we have is to change one of the equations by multiplying so that two of the terms will be the same. Here, this gives you even more control than ever. You get to decide. Now, when we have that control and we have decisions to make, that's where we can make mistakes, or that's where sometimes we're unsure of what to do. But that means we're just going to have to practice. So what I want to do is I want to actually, on both sides here, I want to multiply times 4. If I multiply times 4, I'll use the distributive property to get 4x minus 8y, and then if I multiply times 4 over here, it's going to equal 52. Well, now, when I take my other equation here and I stack it, it goes down here, down at the bottom. I get 4x plus 3y equals 8. Now, do you see what we've done? We've got two equations that have the same x term. That's really nice. So I'm going to subtract these two. 4x minus 4x is going to make nothing. Then a negative 8y minus 3y gives me a negative 11y. And then a 52 minus 8, that should be, what is that, 52 minus 8? So that should be a 44. Look at that. That turns out really nice, doesn't it? I divide by a negative 11 on both sides. And what do I get? Y equals negative 4. Now, I'm not done, but it sure does help me, doesn't it? So now if I go back to my original equation, x minus 2y equals 13, and I plug in that y is a negative 4, I've got x minus 2 times a negative 4 equals 13. This actually makes a positive 8, so x plus 8 equals 13. If I subtract 8 on both sides, I find out that x equals 5. X equals 5. That should work. When I go to plug those numbers back in, my value should be correct. So I've got 5 comma negative 4 is my solution. And the smiley face, or some kind of grumpy face or sad face. I'm not quite sure. Moving on. Here I've got negative 3x minus 4y equals 27, and 5x minus 6y equals negative 7. I need to decide what I want to do. Do I want to make the y terms the same, or do I want to make the x terms the same? I get to choose, and actually, there's not any reason why I couldn't do either one. I think that I would go with the y terms. They'll end up being slightly smaller, I think. So for this one, can I just multiply one of these equations to get them to be the same? No. I'm going to have to actually multiply both of them. So here, for this top equation, I'm going to multiply times 3. And here on this bottom equation, I'm going to multiply times 2. What that does for me is when I rewrite this one after I've multiplied, I'll get a negative 9x minus 12y is equal to, and then I've got like 81, I believe. And then down here at the bottom, I'll have a 10x minus 12y, and that equals a negative 14. Now I've got two terms that are exactly the same. When they're exactly the same, that means I need to subtract them. So if I subtract a negative 12, that's like adding 12, and these will cancel out. Well, then I get a negative 9 minus 10. That gives me a negative 19x, which, you know, seems pretty crazy. But when I do 81 minus a negative 14, I'll actually add 14, and that gives me 95. Now when I go to solve for x, I divide by a negative 19 on both sides, and I believe that 95 divided by negative 19 is going to give me a negative 5. Okay, and that's one of my solutions right there. Well, now I'll go back in and I'll take one of my first equations. I'll do negative 3x minus 4y equals 27. I'll draw a line down here so we can separate this. I'm going to plug in the fact that I've figured out that x is actually a negative 5. Minus 4y equals 27. This now makes a positive 15 minus 4y equals 27. I will subtract 15, which makes a nice, neat 12. So negative 4y. Negative 4 times y equals 12. Well, once I divide by a negative 4 on both sides, I get y equals a negative 3. In the end, when I'm all done, here's my answer up here in the corner. I get a negative 5 comma negative 3, and that's my solution. And I'll try a new smiley face this time. That's goofier, less sad this time, but I think I still need to work on those. All right, moving on. Ooh, solve by using any method. All right. Well, here's the thing. I've got decimals here. I've got, boy, I got all kinds of stuff going on. I think what I would probably want to do, what I could do is I could make this into a 1. That would be nice, right? I can multiply this term times 5 and make that a 1x. That would be good. Or I could turn this into a negative 4.5 by multiplying times 3. Either one of those would work. I'm guessing, let's see, I'm going to go ahead and go with, I'm going to multiply this top equation times 5. All right. So if I do that, I'll end up with x. So 5 times 0.2 is going to give me 1. And then 5 times a negative 1.5, that gives me a negative 7.5y, and then a negative 5. Down below that, I still have an x minus 4.5y equals 1. Now I have to decide what I want to do. I'm going to subtract those two equations. So x minus x makes 0. And then a negative 7.5 minus a negative 4.5 actually means I'm going to add 4.5. So it brings me all the way down to a negative 3y. Negative 5 minus 1 gives me a negative 6. Then I divide by negative 3 on both sides. Y ends up equaling 2, which is pretty nice. Then I go back to my original equation. Let's say I'm going to use this one, x minus 4.5y equals 1. I plug in that y equals 2. So I'm going to subtract 9 from x to get 1. So once I add 9 on both sides, I find out that x equals 10. So in the end, my solution is 10, comma 2. Not so bad, right? One more time. Maybe a little more mischievous this time. No, not bad. I'm still making improvements. All right, here. Let's go full screen on this. All right. A rectangle has a perimeter of 18 inches. A new rectangle is formed by doubling the width and tripling the length, as shown. The new rectangle has a perimeter P of 46 inches. Write and solve a system of linear equations to find the length and width of the original rectangle. Oh my. Okay. And then find the length and the width of the new rectangle. All right, this one's going to be interesting. So I've got an old rectangle that has a normal width and length, right? And then I have a new rectangle that's going to be bigger. We're going to double the width and we're going to triple the length. So when I look at my very first rectangle, here's what I know is true. I know that 2 times the length plus 2 times the width is going to equal this amount right here, this 18. But for my next rectangle, what happens is, and let me switch here. For my next rectangle, I know that I'm actually going to triple the length. So double that. And then for the width, I double that, so it's 2 times 2w. And in the end, that's supposed to equal 46. So my new rectangle, or my second rectangle, is actually, the equation that I'll have for this is actually going to be 6L plus 4W equals 46. Well, says write and solve a system of linear equations to find the length and width of the original rectangle. Well, I'm in pretty good shape right here. These are my two. I'm going to do great here because I've got 2 rectangles. I got 2 true statements that I can use and I can solve with. I'm going to let you guys pause here for a second and see if you can use these 2 equations to find your well, the first one is the original rectangle, but then for the second part, you're going to need to find the new rectangle. So hopefully you've worked on it a little bit, but basically what you want to do is you're going to take these 2, you're going to stack them back up. I've got 2L plus 2W equals 18, and then 6L plus 4W equals 46. I think, I mean, there's a lot of different ways you can go, but I think what I would do is I would just multiply this equation times 2, so that now I'm going to take all of this and I'm going to rewrite it down here. It's going to be 4L plus 4W is equal to 36. And if I have that, so I'll kind of get that out of the way now. If I have that all set up, now I can just subtract to get 2L. 4W minus 4W makes nothing. And then 46 minus 36 just makes 10. If that's really the case, boy, this is pretty easy. That means I now know that L equals 5. Okay? If L equals 5, that works for me for both my old rectangle and my new rectangle. Now that I know L equals 5, I can go back and say 2L plus 2W equals 18. I put in 5 for L. So that's 10 plus 2w equals 18. I subtract 10 on both sides. This is an 18. So now 2w equals 8. I divide by 2 on both sides. I find out that w equals 4. Okay, so that's my solution. I know that L and W make 5 and 4. My original rectangle is, let's go, L is 5, and my width is 4. On my new rectangle, I'm going to have to do 2 times 4, so that makes 8. And I'm going to have to do 3 times 5, so that makes 15. So in a regular problem, you might go back to your old equations. These are a little bit more simple, or it maybe makes a little bit more sense because you're applying it to your rectangles and it really means something. Okay, one last problem. There are 15 workers employed on the highway project, some at $180 per day, some at $155. Daily payroll is $2,400. Let X represent the number of $180 per day workers, and let Y represent the number of $155 per day workers. Write and solve a linear system to find the number of workers employed at each wage. I would really, really like for you to pause for a second and see if you can come up with 2 true statements. If you can go from there, you should be able to solve this one. Now, I'm not going to make you wait for too long. I really would like for you to pause here and work on it. But here are your 2 true statements. X plus Y is going to equal 15. And also you've got 180X plus 155Y, and that equals 24. If you use these 2, you should be able to find your solution. Hope you guys have a great day. That's my best smiley face yet. Your homework for tonight, let's look at it, is page 454. You're going to do 2 through 18 the evens, 22 through 32 the evens, 38 and 40. Now, make sure you actually, I really do want you to cross off 14, 18, 24, 28, and 40B. And watch out for number 22 because there's fraction. Okay, have a great day, guys.